I remember during my time in high school, that day we feel a subtle, gentle shaking. Then the emergency alarm were ringing throughout the school. Everyone's panicking and start gathering into the hall. And later we learned it's because of the earthquake that occurs in our neighboring country, Indonesia. So now imagine the same situation occurred in Sabah with larger magnitude 6.0 in 2015, specifically within Mount Kinabalu, that's said to be the largest earthquake to strike Sabah in the past century, killed 18 hikers and caused significant damage to the town nearby. This is an unexpected event occurred in a region of very low historical damaging earthquakes. The question is, what caused this earthquake to happen and how can we predict it? Imagine we are trying to break apart two good blocks. We put all of our energy in separating the blocks, and then when it's break off, you will find even your hands shaking. So you can imagine the same thing occur after two Earth's crust slide past one another after having been locked together for a long time. The magnitude of earthquake is related to the length of the fault on which it occurs. No scientists have ever predicted earthquake, but a number of studies can be done to calculate the probability of a significant earthquake will occur by studying the active faults. So this is what I'm doing, trying to identify the faults. In my research, the identification of active faults and other geological features is accomplished using remote sensing, complemented with gravity data. We have passive remote sensing and active remote sensing. Passive is when the sensors detect the electromagnetic energy from natural sources such as sunlight. Even we ourselves are equipped with passive senses. Our eyes, it can see the reflected electromagnetic light that is emitted by the sun. Active senses, as opposed to the passive, produce its own electromagnetic energy and measure its reflection. I use radar satellite images such as pulsar, that is a product of the active senses, to identify lineaments on the study area. Besides lineament, through optical satellite images such as Landsat 8, I can also identify the lithology of the study area based on different spectral colors to get more idea about the geology of the study area. Each material has their own particular wavelength, like different objects give different colors. So with these colors, I can identify either it is sedimentary rock or igneous rock. But wait, did I mention gravity before? Why do I need to use gravity method? As explained before, remote sensing gives the surface interpretation, so I'm using gravity data to interpret the subsurface of the study area, because the earthquake may be resulted from the rupture of fault that does not appear on the surface. From the gravity method, we can detect the density value of the material, and the abrupt changes of low value to high value may indicate a change in the lithology and may also indicate a fault. So from the remote sensing and gravity method, I can identify the potentially active faults that may trigger the earthquake, and these results may contribute into producing hazard maps in Sabah. Thank you.